Okay, happy day and welcome everybody. Today we are talking about chemical changes, physical changes, but then what we're going to do is we've got a chemical change lab for you. Okay, so the first thing that we're going to do here is we're going to get started on looking at just getting some background information before we actually start the chemical change lab. Okay, so the first thing is what's matter. We've talked about this multiple times, so I want to say this is probably take number 4 on what is matter. It's everything around you. Everything in the universe, it's made, it's atoms, it's molecules, it's you, your body, your shoes, the chair you're sitting in, and the air that you're breathing, right? So every single thing is made of molecules and molecules and atoms are matter, okay? So even though matter can be found all over the universe, you usually find it in a few different forms. Scientists have identified 5 states of matter. 3 of them you already know. One of them where the molecules are really, really close together, that's called solid, very good. And then when they're a little bit separated, they're called liquid. And then when they're really separated from each other, they're called gases. So there are 2 more. And so one of them, and we're not going to be talking about these 2, but one of them is plasmas, which is actually an ionized state of matter where, we talk about how you can form ions, which just means that the atom carries a charge, right? And so there's a different state of matter there, and then there's what are called Bose-Einstein condensates, and those were scientists got the Nobel Prize for that in 1995. Okay, so we're only looking at those first 3. Matter can be categorized as substances or mixtures, but what I will tell you is a lot more common is when you dissolve a solid into water, and that is called a solution. Okay, and so I want you to underline dissolved in water, and these are called solutions. Everybody say solution. Okay, sometimes they'll call them homogeneous solutions, and the reason why they'll call them homogeneous is because everything looks the same. So they'll call it homogeneous because it all looks the same. So this one is, and you'll be using this one in lab, this one's called sodium carbonate, and this one's called copper nitrate. And so all I did is I took some of the solid and I added distilled water to it, and then now it creates a solution, okay? And so those are 2 examples of solutions. Okay, so we know this. On the count of 3, matter is anything that has, 1, 2, 3, mass. Very good. And takes up, 1, 2, 3, space. Very good. And takes up space. It exists in 3 states. What 3 states did we say?
Solid, liquid, gas.
Awesome. Solid, liquid, and gas. Awesome. When we mix a compound in water, what do we say we call it?
Solution.
Solution. Very good. We call it a solution. Awesome. And so, difference between a liquid and a solution. So, a liquid typically is going to be if you have, let's say you have a piece of chocolate and you melted it down. Now it's in its liquid state, okay? But if you're dissolving something in water, which usually it is, like if you have contact solution, for example, and there's stuff in water, even like hydrogen peroxide, alcohol, those are all water-based 2 things that they have where they'll dilute them down, then we're gonna call that a solution, okay? Okay, so before we get into chemical changes, because that's what we're gonna focus on, let's talk about physical changes, okay? So what's a physical change? This is simply any change made that keeps the chemical formula the same. Awesome. It will stay the same. So if it's a physical change, then things are going to stay the same. What do we mean by that? Well, if we take a look here, this arrow is pointing toward the ice that's on top, and that's water in the solid form. And if we look here, these big circles, water we know is what formula?
H2O.
H2O. So you can see there are 2 little whites, and then there's a bigger kind of bluish one. I always call this like it looks like a Mickey Mouse molecule, okay? So that's kind of the shape that water takes on. Anybody want to guess what the 2 small ones must be? Why H's? Why would the 2 smaller ones be? Because there are 2 of them, perfect. So these little ones are actually H's, and then the bigger one is going to be an O. Now notice over here in the liquid water, so now it melts, right? So the solid ice melts. Notice in the liquid, do we still have 2 H's and 1 O? Yes. The molecule is exactly the same. This would be an H, this would be an H, and that would be an O. What is the difference? Now, usually, I'm not going to even say usually, I'm going to say in every single situation except for water, okay? Water does a weird thing, all right? So except for water, When you say solid, how would you tell someone what happens to the molecules in a solid versus a liquid?
It stays in
And it's solid, it expands.
Which ones are closer together?
Liquid.
liquid. No, solids.
Solids, very good. Solids should be, the word I'm looking for starts with a D. Solids should be more, starts with a D. Dense, very good, okay? Solids should be more dense, which means if you drop a solid in its own liquid, so let's say I have melted down gold, okay? And I take a small cube of gold, of like actual solid gold, and I drop it into the melted gold. Where would you expect the solid to go? To the bottom. It should sink, okay? So we know that things that are more dense sink, right? Why is it that a piece of wood, when you throw a piece of wood into water, what usually happens? It floats. Why does a piece of wood float above water? Because the wood is
No, it's
less
not that. Yeah,
dense.
it's not that.
What does that mean? There's more what in between the molecules? There's more space. Okay, or air, right? So if there's more air in between and there's more space in between, it's less dense and then it's gonna float. Water is the only substance that does this. The solid state, it's organized. It's definitely more organized. The liquid state is not organized. But what do you notice in liquid water versus solid water? What can you tell me about the amount of space? There's more space here, which is why what happens when you drop an ice cube into liquid water? It floats to the top. It floats. Okay. So ice cubes, that's why it is the only substance that does that. So almost every other substance that we will ever come across on Earth will sink when you put it in its own liquid. Okay. Okay, so a phase change is a physical change, so it's still water. I'm changing it from one phase to another, but it's still water. So because of that, that's called a physical change. Okay. And so the basic chemical structure does not change. Very good. Does not change.
So example is just water?
Examples. Oh no. Give me some physical changes. What are some changes that you could do to something that would just be a physical change?
Cutting something.
Okay, cut something up. I like it. Cut it. Okay, so if you change the chemical formula, it's going to be a little bit different. Do what to it? Melt it. I like it.
Freeze it.
Freeze it.
Boil it.
Boil it. Now, we're going to come to burn. I like this, okay? So there's a difference between boiling and burning something.
What's the difference between burning and
Can you get it back if you burn it? No. That's my rule. Usually my rule is if you can get it back, it's a physical change. If you can't get it back, it's probably a chemical change, okay? So we're going to do some chemical change words too in a second, but burning, for example, you can't get it back. What if something rots? Can you get it back again?
No.
No. What if something rusts? Can you get it back again?
Yeah. You can unrust it.
Oh, you would think you can. I thought you can. You actually cannot. If something rusts, if you go to clean it off, you literally are just that part of the car, let's say your car has rust on it, will be gone. It'll be gone, okay? So it's a chemical reaction. So that is a chemical change that's actually happening. So cut, melt, freeze, boil. There is one more that I want to do on here, and I know that people are going to say the wrong one, but it's okay, all right? So one of them is a chemical change. It starts with the letter D. And this one, if you do this particular thing, then you can get it back. You can get it back again. It's just not as obvious that you can get it back. So take a guess. Some letter D words
Destroy.
not destroy, not destruct, not decompose, but I like it. Dissolve. Very good. Very good. You said somebody else said it?
said it first.
I missed it. I'm sorry. Good. Okay.
I said it first.
Okay, good. Dissolve. Now, if something dissolves, how is it that you can get it back again? Let's say I put salt in water. Okay, how can I get the salt back again? Evaporate it. You can either just let it sit and eventually the water's going to all evaporate and the salt's going to be left behind, or what else could you do to it to make it go faster? Well, if you strain it, it's salt water. It's going to look just like how this does, where it's just going to come right through the bottom. So if you start to heat it, you're getting at this. If you start to heat it, and then the water will boil, right? And then you can boil off the water and just be left behind with the salt. Okay, as long as you don't burn the salt. If you burn the salt, that's a chemical reaction. That's a chemical change, okay? Okay, so those are physical changes. Now let's talk chemical changes because this is what the lab is about. This is any change that produces a new
element, what's it called?
Compound or substance. So you can say, the reason why I like to say substance is because it could be an element or a compound, okay? Which we're going to do, let's do that right now, okay? So, at the, I don't know, where on your page do we have a little bit of space? Maybe like right over here on the side here. I want to make sure that you know the difference between an element and a compound. And so this tended to be very confusing for some students, and I think it was the reason why they couldn't categorize. You're going to need to categorize a type of reaction when you're doing the lab. And they were very confused because I was like, well, use your giveaway. And so I'll show you the giveaways. We're going to go through giveaways. And they couldn't figure it out. And I think it's because they just didn't know the difference between elements and compounds. So I'm going to write EL for element like this. And then I'm going to write capital CMPD for compound. And then I just want to list a few elements and list a few compounds. Okay? Okay, where do I find the elements? On the what table? Periodic table. Those are all elements on the periodic table, okay? I want you to notice that every single element, if we look at an element, it's going to have one capital letter or one capital letter and a lowercase letter, okay? It's not going to have two capital letters. For example, which one of these, CO or CO, is an element? On the count of three, is it A or B? Which one is an element? Ready? 1, 2, 3, go.
B.
B. Very good. This is cobalt. This is not cobalt. This is carbon. It's called carbon monoxide. It's called carbon monoxide. Remember we talked about carbon monoxide when we were saying you have carbon dioxide or carbon monoxide. Yeah. Carbon monoxide can kill you if you to get those detectors. So that's carbon monoxide. That's cobalt. Two completely different things. This is a metal. This is a gas that can kill you, okay? So they're very different. So the elements, let's just list some elements. So something like sulfur, something like magnesium. Give me another one.
That's my favorite. N. Sulfur.
Okay, nitrogen, which nitrogen would still be N2. Even though there's a 2, it's still just one element. I heard,
S.
Yep, I got S, I got sulfur.
AS.
Arsenic, very good, AS. Maybe a couple more. PB is lead. Lithium is Li. Ti for titanium. Okay, are we good?
What about W? What is W?
Okay, W is called tungsten. So those a lot of times are used in like filaments for lights, for like light bulbs, with the tungsten. Okay, now, what about compounds? Give me one that is vital to our lives.
H2O.
H2O. Give me another one that's, oh no, that would fall under this one. Oxygen would be up there, okay? O2 would be up there. But if we say H2O, that's two capital letters. That's a compound, okay?
CO.
CO, okay. How about, anybody know the formula for sugar? Or we can even do glucose instead of sucrose. There's a C6. Anybody know where I'm going with this?
Wait.
C6H12O6. In bio, you may have seen that reaction because when you're doing photosynthesis and respiration, you would see, this is glucose, not sucrose. That's not the one you eat. The one you eat is almost double. It's C12H22O11. Okay, let's do one more compound. Anybody want to do like maybe salt? What's the formula for salt?
Isn't it like
NaCl, very good. NaCl, awesome, okay? So difference between elements and then compounds, okay? All right, so now let's talk chemical changes. What happens in a chemical change is, let's say I have magnesium, well then after it chemically changes, it still will have magnesium in it, but it's not gonna be just magnesium. It might be magnesium oxide, okay? This is going to be one of the stations you're going to do. So there are going to be 6 stations that you're going to go to. If you take a look at this right here, this is a piece of magnesium, and it's bendable, okay? This is a bendable piece of magnesium. It's shiny. It's silvery. You're going to see, I will show you this when we go to do the stations. This is one that I do want to show you before we actually do it. You can't look at it, directly at it. It will hurt your eyeballs if you look directly at it. And so it burns very, very, very hot. If they need, if they can't get heat high enough to start a reaction, a lot of times they'll burn a piece of magnesium and throw it in. So there's a reaction called the thermite reaction. We've done it before. My independent studies have done it before, and we actually had to get the fire department to, like someone from the fire department to like watch to make sure that everything was going to be okay. But we did a lot of it. That's why if we did a smaller version, we would have been okay. But we used magnesium to set it off. Okay.
Wait,
Okay.
So we can't look at that today?
So you're gonna look at it, but you're gonna use your peripherals. So you're not gonna look directly at it, and I'll show you. Okay, I'm gonna demonstrate. That's one that we'll do together first. That way, when you get to the station, it's not like a big surprise for the group that does it. Okay.
He's Superman.
So there is evidence of a chemical change. If you see something like, let's say, you bit into an apple and left it on a table. Okay.
Rot.
How do you know that it rotted? What happens to it? It changes colors, okay? It changes colors. That changing colors typically means that you had a chemical change happen, okay? So the change of colors. But let's go through these and let's see what do you think this is showing? And by the way, there's no heat added to this. This is literally like you mix two chemicals together and this, what do you think I'm referencing? What's happening in this picture? Bubbles, gas form, very good. So this one is bubbles. And so there's gas forming, and I'm going to write underneath it, no heat added. No heat added. So that's with no heat added, but bubbles form. So you mix it, and you get bubbles. If you heat it up and you see bubbles, what is that probably? What's probably happening? It's about to start boiling. Yeah, then it's about to start phase changing, and a phase change is not a chemical change, okay? This, yes, it's color changing, but that's not what I'm looking for. Anybody want to guess what happens? So they're mixing, this was in one of the WebQuest videos, and this is going to happen. You mix two chemicals together, and it looks like you formed what? From the two,
What?
it starts with a P.
P.
So it's a long word that starts with a P,
Photosynthesis.
and it's actually a solid that formed from two liquids. It's, okay, I'm going to give you another hint. What'd you say? No, it's the same word, and I don't know if somebody said it's the same word that they use when weather people say that there's snow or sleet or rain. Precipitate. Very good. It is called a precipitate. This is a solid that forms from two liquids. This is a, I'm going to write a solid forms. Now, it doesn't look like a solid. What you're going to do in the lab is there's going to be a piece of filter paper under a funnel. And so what you're going to do is you're going to pour what you made onto the filter paper. If it goes right through the filter paper, color and all, then it is not a solid. It's a liquid, okay? It's an aqueous or it's a liquid. If it stays on the paper, it's probably a solid, okay? And so what do we call that? We call it a precipitate. We call it a precipitate. Okay. What's happening here? This is a pretty easy one.
Explosion.
Exploding, or what else can we call this? Sparking. There's light. There's light that comes off. We're going to say exploding. We're also going to put down, because burning would also be, so if it was exploding, if it was burning. So we can see that there's the evolution of energy, and a lot of energy that's being given off, okay? So lots of energy. And it can either be energy in or lots of energy out, but usually when you see something like that, that's a chemical change, okay? And then this one was clear, but now it's pink. That would simply be a color change. Perfect. This is a color change. Okay, awesome. Okay, so when you're going to want to use these words when I ask you for evidence in the lab, but I'm also going to ask you for an observation. So when you get into the lab, I'm going to say, write your observations and provide evidence. So which one of these are you seeing when you go to do that? Sometimes you might see two things that are happening. Okay, so there's going to be a part where I'm going to ask you what the type of reaction is, all right? And so we're going to do this. You might need to just keep flipping over to the other side to see these, the giveaways, okay? The first giveaway, synthesis. There's another word for synthesis that on different websites or different like learning sites or textbooks, they'll use another word for synthesis, and the word is combination. Anybody want to guess why? What's happening in synthesis?
You're combining.
You're combining things. So what I want you to do is, I don't care what we start with, but there's an arrow, and then you're going to end with one new compound. There can even be a coefficient in front of it, that doesn't matter, but there's only one compound and there's no plus sign with something else. It's literally just one compound, okay? So that's gonna be synthesis. If we have decomposition, what do you think is happening there?
It's decomposing.
It's decomposing, which means it's probably breaking down. I like it. Let's just say breaks down.
Like that would be dissolving.
I didn't mean to put quotation marks. Actually, we don't need quotation marks. But if you see that something is something breaks down, then that would be breaks down. That would be decomposition. Okay, so in this one, you're going to see one compound on the left, and then you're going to have an arrow with multiple stuff. Again, you can have a coefficient in front. The coefficient can say 3, but there's no other plus sign. All right. Okay, let's try single replacement. So single replacement and double replacement. What happens in single replacement is, let's say you're playing on a team and you're on the sideline and somebody gets injured, okay? And let's say it's their, I don't know, it's their first base that just got injured, right? What's gonna happen is you're gonna go in and that person's gonna come out, right? Okay, so that's what's gonna happen in single replacement. In double replacement, I also call this double dating. You can either think of it in this way. You go on a double date and then you switch dates. That's double dating. Or let's do the team situation, okay? Let's say that this row of people is on one team and these 5 people are on another team. And let's say that on this team, we have 2 really good forwards. And on this team, I say, hey, everybody, from this row right here, who's a good forward? Who wants to play forward? And they all look at me. They're like, I'm not good at forward. I'm a defenseman. I'm really good at center, but I'm not a good forward. So what I do is I'm like, okay, well, they already have one good forward. I'm going to switch you with you. You go there, and now our teams are more even, okay? So it would basically be both of them are still playing. They both will still be on the team. We just switch teams, okay? So that's what's going to happen in double displacement versus single replacement. Okay, so what does it look like? Single replacement, what is that? Elements. There's one of them is an element, and then there's going to be a plus sign, and the other one will be a compound. Okay? Now, I'm going to write what would happen after that. What would happen after that is the element, let's say, and one of these are going to switch places. And by the way, it could be compound plus elements. Okay? So the plus sign, it doesn't matter which ones. It's like 2 plus 4 or 4 plus 2 are the same. It works the same way here. So it doesn't matter which order it's in. So what can happen is my CM can come out, and then I can end up with ELPD. Okay, so they switch places is basically what happens. So if you see that, that's called single replacement or single displacement. Okay, they use 2 words for that. Okay, double replacement. In double replacement, what's going to happen is I'm going to have 2 compounds. So it's going to be CMPD plus CMPD. Okay, but I'm going to put a little X on that second one just to make it different. Okay, just to make that one different. Okay, so what's going to happen on this one is 2 of them are going to switch places. Okay, so let's say I switch places like these 2 right here, switch places. So what I'm going to get is I'm going to get CMPDX, and then I'm going to get CMXPD. So if these 2 switch places, then I'm just going to swap them out, okay? So if you see 2 compounds, that should be your sign that it's got to be a double displacement. Both of them are switching, but they're still both playing. They're 2 compounds, okay? And the last one, what do we think combustion is? In combustion, something what? Starts with a B. Something?
Burns.
Burns. Very good. So in combustion, we're going to write down here that this is burning. If something is burning, then that's combustion. What feeds a flame? Oxygen. Very good. How many of you knew that? Like you've heard that before. Oxygen feeds a flame. That is what makes combustion. So on this one, the only thing we need is plus O2 on the left side. It does have to be on the left side in order for it to be combustion, a combustion reaction. Okay?
Wait, where's the compound?
So it could be, the compound would be on the other side of the plus side. So you can say O2 plus the compound or the other way around. Okay? All right, so here's what I wanted you to do. We're going to take a look at some of the reactions, and I want you to tell me just a couple of them, okay, maybe 2 or 3. I want you to tell me on the count of 3 if you think it's one of these 5. Synthesis, decomposition, single replacement, double replacement, combustion. Please don't answer until I do a countdown, okay? All right, so let's take a look. Okay, so I'm going to do this one first. Let's do this one first. Okay, so what I want you to do, and by the way, this is CL, not CI. That is a lowercase l. That's a lowercase l, okay? Which means this one and this one are both what? Are they elements or compounds?
Elements.
They're elements. Okay. So I want you to take a look at your list down on the bottom, and then I count of 3. I want you to tell me, is this combustion, single displacement, double displacement, synthesis, or decomposition? Okay, so let me give you a second here. Okay, it's only one of them. This one's only one of them. So on the count of 3, ready? You know it. 1, 2, 3, go.
Synthesis.
Synthesis, very good. What is making this one synthesis? Yes, there's an arrow and then there's one compound. Again, there could have been a coefficient in front of there. That doesn't matter. As long as there's no plus sign over there, okay, then it would be synthesis. Okay, let's try another one. Let's do this one right here. Okay, don't say. Please don't say. This one right here. Okay. So on the count of 3, so take a look at your list. Is this an element or a compound? ZN, is that an element or a compound? Element. Is this a compound or an element? Compound. Anytime you have more than 2 elements, capital letters, it's got to be a compound. Okay, ready? On the count of 3, which one's this? 1, 2, 3.
Single replacement.
Good. Single displacement or single replacement. Very good. So SD, single displacement or single replacement. Let's do one more. Okay, I have a good one. Okay, this one right here. Okay, there are 2 correct answers. There are 2 correct answers. Okay, go ahead and look at your list. Okay, and then when I do the countdown, give me one of the correct answers. Okay, 1, 2, 3, go. Synthesis, very good. Why is it synthesis? Because we're making one compound. What else is it? What did you say? Combustion. Why is this combustion? Because there's oxygen to the left of the arrow. And the oxygen has to be to the left of the arrow, okay? Okay, I hope that was a good introduction to chemical reactions. We're about to get started on the lab, so we'll see you very soon.